Hello everyone. Today we will learn about long distance propagation in mobile communication. Long distance propagation. See, coming to long distance propagation, its advantage is if we take the high cell site, if we take the cell site area, if we take the cell site height, high cell site, then it can cover the signal in large areas. If we take Hello everyone. Today we will learn about long distance propagation. Long distance propagation. In this long distance propagation, we will consider the height of the cell site as high. The height of the cell site is high. Height of the cell more height. Then its advantage is it can cover the signal in large areas. As the height of the cell site is high, it can cover the signal in large areas. And the second advantage is it can even cover the signal in a noise limited system. It can even cover the signal in a noise limited system where several frequencies are repeatedly used in different areas. It means several frequencies are repeatedly used in different areas means the concept of frequency reuse which we had learned earlier. The concept of frequency reuse where we use different same frequency again and again at long distances at different cell site, the concept of frequency reuse. So here it was said that using the high cell site, its advantage is it can cover the large area, and the second advantage is it can cover the signal in a noise limited system. In this noise limited system, we use several frequencies where several frequencies are repeatedly used in different areas. What is here noise limited system? What is meant by noise limited system? Here noise limited system means when the mobile unit moves away from the base station. When the mobile unit moves away from the base station, then the received signal power decreases. We already know that when the mobile unit moves away from the base station, the received signal power of the to the mobile unit decreases. And at a certain distance, the SNR, it means signal to noise ratio, does not achieve the required threshold value for reliable communications. It means the communication becomes difficult. It means there occurs interference when SNR, signal to noise ratio, does not achieve the required threshold value. This is noise limited system. Here it is said that it can cover the signal in even in a noise limited system. But in the noise limited system, if the traffic, if there is an increase in the traffic, then there occurs interference. So, in noise limited system will become an interference limited system whenever there is an increase in the traffic. Clear? This is about noise limited system and how the interference is occurring even in the noise limited system due to increase in the traffic. So we must be aware that the interference is not only due to the adjacent channel or co-channel interference, but it is also due to the long distance propagation. Okay, due to long distance propagation, there occurs interference also due to not only due to adjacent channel interference and co-channel interference, but also due to the noise limited system when the traffic increases in the noise limited system. Now, in long distance propagation, we will study about two cases. The first case is within a 50-mile distance, within a 50-mile radius, within a 50-mile radius. So, if we consider within a 50-mile radius, how the signal is propagating. We will study how the signal is propagating. So, within a 50-mile radius, for a high cell site, the propagation path of a ground wave is not a straight line. The propagation path of a ground wave is not a straight line. It means the wave is propagating in upwards and downwards. It means the wave path can bend either upward or downward as shown in the figure. when this wave is propagating either upward or downward, when we consider the sea water, when we consider on sea water, it means at this and this incident is noticed more on sea water because the situation of atmosphere over the ocean is varied depending on the variation of altitudes. So the explanation of this first point within a 50-mile radius, it means the if we consider over the sea water, how the propagation is going on if we consider over the sea water. So if we consider the sea water, due to change in due to different variations in the altitudes, the propagation of wave, it is moving either upward or downward as shown in the figure. This is when we consider within a 50-mile radius. When we consider within a 50-mile radius. Now the next case is within an area of 200 miles. So in the second case, we will consider an area of 200 miles or 320 kilometers. When we consider an area of 200 miles or 320 kilometers, here we will take the tropospheric area. The tropospheric area means the layer above the Earth's surface. The layer above the Earth's surface. So in tropospheric area, for long distance, the tropospheric wave propagation prevails at 800 megahertz. So here it was considered 800 megahertz, and how the tropospheric wave propagation is going on. We will study how the wave is propagating in this tropospheric area. Clear? So in this tropospheric area, the wave propagation, it means sometimes the signal can even reach 320 kilometers away because of change in dielectric constant of the troposphere. So in the tropospheric area, due to the change in dielectric constant, there exists the propagation of wave propagation in tropospheric area in different ways due to change in effective dielectric constant. Here you have to remember that this effective dielectric constant changes with the temperature, changes with temperature in the tropospheric area. See, here as dielectric constant varies with temperature, as temperature changes, the dielectric constant also changes. So here we will consider again the temperature. Coming to the temperature is inversely proportional to the height. It means as we move from Earth's surface to the tropospheric area, it means as we move higher from Earth's surface to the tropospheric area, the height is increased. The height, the altitudes are increasing. If the height is increased, then here what is the condition? The temperature is inversely proportional to the height. It means the temperature decreases when we move to the height areas. When we move to the altitudes are height, the temperature decreases. Here the temperature decreases, the dielectric constant also varies with temperature. As dielectric constant varies with temperature in tropospheric area, there exists the propagation of wave in tropospheric area in three ways. There are three ways in which a tropospheric wave is divided. Here, why the a propagation wave is divided into three ways in a tropospheric area? Due to change in dielectric constant. Why this dielectric constant is changing? Due to change in the temperature. How the temperature is changing? Due to increase in the altitudes of height. Due to increase in the height, we know that the temperature decreases. That is, temperature is changing. As temperature changes, dielectric constant changes. As dielectric constant changes, the tropospheric wave is divided into three ways. That is, tropospheric reflection, tropospheric refraction, and moistness. So coming to tropospheric reflection and refraction, in tropospheric reflection, here the reflection takes place where the atmospheric changes, where there are atmospheric changes in the dielectric constant of the atmosphere. The same what we had said earlier, it is repeated again. It is repeated here. It means the reflection takes place. The tropospheric reflection takes place when there are atmospheric changes in the dielectric constant. It means we know that the dielectric constant changes with the temperature. We know that the temperature changes with the increase in the height. So here it is saying that as the atmospheric changes, due to the atmospheric changes, the dielectric constant, the reflection takes place where there are atmospheric changes in the dielectric constant of the atmosphere. So here the distance of propagation is much greater than the line of sight propagation. Compared to the line of sight propagation, the distance of propagation is much greater. That is what we had written here. See here in the first page, sometimes the signal can reach even 320 kilometers away. It means long distance propagation due to change in effective dielectric constant of troposphere. The same it is repeated here. The reflection takes place where there are atmospheric changes in the dielectric constant of the atmosphere. So in this condition, the distance of propagation is much greater than the line of sight propagation. Then coming to tropospheric refraction, the same explanation here also, but there is a bending of wave. The refraction represents here is a bending of the wave due to changing of effective dielectric constant of the atmosphere through which the wave is propagating. It means here the bending of the wave due to change in dielectric constant. Due to change in dielectric constant, the wave we observe that there is a bending of wave through which the wave is propagating. So in these two cases, in tropospheric reflection and tropospheric refraction, there is a change in dielectric constant with respect to the temperature. Here, as temperature is changing, there is a change in dielectric constant. As dielectric constant is changing in the atmosphere, there exists propagation, tropospheric reflection and tropospheric refraction in wave propagation. Now coming to the moistness. In moistness, here the dielectric constant of atmosphere is much affected with the water content. It is not affected more with temperature. In the above two cases, tropospheric reflection and tropospheric refraction, we had studied that the dielectric constant of atmospheric is affected with temperature. But in moistness, we are studying that the dielectric constant of atmosphere is affected with water content in tropospheric area. Water content means we know that in tropospheric area we had water vapors, particles, gases, etc. Okay, so this water content, due to the effect of water content, there is a change in dielectric constant of the atmosphere when compared to the temperature. So that we know that the water vapor pressure decreases with increase of height. Water vapor pressure decreases with increase of height. Due to these variations, there exists the propagation of wave. So this is the another effect which occurs during the propagation. So in this propagation, this is also called as duct propagation. Duct propagation means it occurs when a layer. Duct propagation means the propagation which occurs when a layer of warm air is trapped between two layers of cool air. It means between the two layers of cool air, a warm air is trapped, creating a duct that can guide and propagate radio waves over long distance. This is duct propagation. So duct propagation means a warm air is trapped. A warm air is trapped between two layers of cool air. Between two layers of cool air, a warm air is trapped, and among these layers the wave is propagating. This is called duct propagation. So this duct propagation, there are two types of ducts, that is surface ducts and elevated ducts. So this is about moistness. Okay, moistness, in which the dielectric constant is much affected with water content. But in tropospheric reflection and refraction, the dielectric constant is much affected with the temperature. Clear? This is about moistness. Finally, here see, this is the tropospheric earth surface, and above the tropospheric layer, and among the atmospheric duct, this is the atmospheric duct between the troposphere and earth layer. and we see the wave propagation, that is duct propagation. This is the duct propagation, duct, duct propagation. Duct propagation means in which a layer of warm air is trapped between two layers of cool air, it creating the wave to propagate to a long distance. Finally, the conclusion of this point is the tropospheric propagation is a common factor which causes interference and can be reduced by using umbrella patterns and directional antennas. Clear? This is about the long distance propagation. Finally, I would like to share one interesting point here, that is coming to the water content. Here, what we had learned here, duct propagation means a warm air is trapped between two cool airs. So I will tell you one geographical condition, that we know that in the ocean currents, it means in ocean currents you will observe cold currents and warm currents. Cold currents and warm currents means warm water and cool waters. This cold currents and these cold currents and warm currents occur due to the temperature. We know that while the our earth is rotating, we know that one side of the area we will had, if we had summer season, and other side of the earth we will have winter season. So the summer season, the area or the countries which are affecting summer season, their oceans are in hot, they contains hot water, it means warm waters. And the oceans near to the winter seasons, they have cold currents, means cool water. So there are some places, while the earth is rotating, there are some places where this warm waters and or cold currents and warm currents mix each other. Cold currents and warm currents mix each other while the earth is rotating. At these places, when the cold currents and warm current mixes, the places where cold currents and warm current mixes, there are some places where the islands are located. For example, the islands called Falkland Islands. In Falkland Islands, the warm water, the cold currents and warm currents mix each other. At this place, the fishes in the water, they goes to the unconscious stage. They go to the unconscious stage and they float on the water. And the people near in Falkland Islands, they easily collect the fishes. They no need nets, or the no need to fish, they no need nets to catch the fishes. They can easily um, take the fishes over the water, as the fishes floats over the water due to their unconscious stage. This occurs due to when the warm currents and cold currents are mixing to each other. Clear? Similarly, here in moistness, we are studying about duct propagation. It means duct propagation means the propagation, the layer in this duct propagation, it occurs when a layer of warm air is trapped between two layers of cool air, creating a duct that can guide and propagate radio waves over the long distance. So this is a simple story I want to add to this duct propagation, which is related to the cool air and warm air or water vapors in the tropospheric area, related to the warm currents and cold currents. Okay, this is about the long distance propagation in cellular mobile communication. Thank you.